everyone, welcome to the online class of nuclei. So we were discussing about the chemical properties of acids and bases, and we have covered the topics such as the reaction of acids with metals or the reaction of base with metals and the reaction of acids with metal carbonates or metal hydrogen carbonates. Now we will move on to the next topic, that is reaction of acids with bases. Okay, what is that? Reaction of acids with bases. How acids are going to react with bases. For that we have an activity. Okay, let's have a look into the activity. Here they have given, take about 2 ml of dilute NaOH solution in a test tube and add 2 drops of phenolphthalein solution. Okay, that we will do first. First, in a test tube, we will take what? NaOH solution. What is meant by NaOH solution? Yes, it is a base, right? Sodium hydroxide. A base that can produce what? OH minus ions. So, in a test tube, we have taken what? 2 ml of NaOH solution. Into this solution, we will add what? Phenolphthalein. What is phenolphthalein? Yes, in the indicators, we have studied about phenolphthalein. It is a synthetic indicator. That means a man-made indicator. Okay, in presence of acid, it will remain colorless, and in presence of base, it will give which color? It will give a pink color. So here we have taken what? NaOH. NaOH means it is what? A base. Into the base, if you will add phenolphthalein drops, what will happen? Yes, the solution of sodium hydroxide will turn into which color? It will turn into a pink color. Okay, now we will look into the activity again. So the color, what is the color of this solution after adding phenolphthalein? Okay, so NaOH was colorless. After adding phenolphthalein, the color of the solution has changed to pink color. Now, add dilute HCl solution to the above solution drop by drop. So here into this solution, we are going to add what? HCl. What is HCl? What is HCl? Yes, HCl is what? An acid, that is hydrochloric acid. Into this pink color solution, when you add HCl, just imagine we have a base. Into that base, you have added what? Phenolphthalein, and it is in a pink color. Into that, if you will add HCl, what will happen? Yes, the effect of that base will be nullified by the presence of what? HCl. Understood? That means the phenolphthalein color will again change into what? Colorless. By the presence of acid. Understood? In the presence of a base, phenolphthalein will give a pink color, and in the presence of acid, the effect of that NaOH will get nullified and the color of that pink will change into what? Colorless. Now, after that, what they have given, why did the color of the phenolphthalein change after the addition of an acid? Why did the color of the the solution has changed to colorless? The reason is the effect of base has been nullified by the presence of what? Hydrochloric acid. Now again into this solution we will add what? NaOH. What is NaOH? Sodium hydroxide, that is a base. Into this solution if you will add NaOH, what will happen? Yes, you are correct. Again that pink color will what? Reappear. Okay, understood? So here it was a colorless. By the addition of phenolphthalein, it will become pink. That shows that it is a base. Again, we will add what? HCl. It will become colorless. That means that it will nullify the effect of what? NaOH solution. And then we will add NaOH. So what NaOH will do? NaOH will nullify the effect of acid. And it will turn into what? Pink color. From here, what you understood? Yes, the effect of an acid or a base can be nullified by adding the acid or base. That means if I want to nullify the effect of a base, I should add what? An acid. If you want to nullify what? The effect of an acid, you should add what? NaOH. Now can we have a look into the reaction of NaOH and HCl? Yes, here if you are taking NaOH plus HCl, okay, what we will get? What we will get? NaOH means it is what? A base, and HCl means it is what? An acid. An acid react with the base will give what? Salt and water. What they will give? Salt and water. Here the salt will be what? Sodium and Cl. That means we will get NaCl, sodium chloride, and remaining will be what? H2O. That's it. So here sodium hydroxide reacts with hydrochloric acid will give sodium chloride and water. So in general, what we can write? What we can write? We can write it as acid react with a base will give what? Salt plus water. Okay? Acid react with a base will give salt and water. It's a very important equation. So for the important equation, we will put what? A tick. Okay? So here this reaction is very important. Acid react with the base will give what? Salt and water. What is this reaction called? Yes, this reaction is called what? Neutralization reaction. Neutralization reaction. When an acid reacts with a base and it gives salt and water, then that reaction is known as what? Neutralization reaction. Understood? From this whole experiment, what we can understand? They can nullify their what? Effect in vice versa. That means acids effect can be nullified by a base and base effect can be nullified by an acid. That's it. Okay. Now we will move on to the next topic, that is reaction of metallic oxides with acids. Reaction of what? Metallic oxides with acid. What is meant by a metal? Yes, metal will always what? Lose electron, just like a base. We have just studied, right? That means base, according to the Lewis theory, base means they will always what? Lose a pair of electron, and acid means they will what? Always gain a pair of electron. Okay. Now they have given an activity. What is the activity? Take a small amount of copper oxide in a beaker. Okay. That we can consider first. We have taken a beaker. Into that beaker, we have added what? Some copper oxide, that is CuO. Into this copper oxide, add dilute hydrochloric acid slowly. Okay, so slowly we will add what? Hydrochloric acid, that is HCl. While stirring, you should what? Stir the solution while adding HCl into copper oxide. Note the color of the solution and what happened to the copper oxide. Do you have any idea? Let's see. Okay, so here we are going to consider the equation, that is copper oxide, that is CuO. Okay, here CuO means it is what? Copper oxide. And this copper oxide is reacting with what? HCl. So here HCl. This copper oxide means, copper means it is what? A metal. And oxygen means we can write it as what? Oxide. So metal oxide reacting with what? An acid. You will get copper chloride. Copper chloride plus H2O. Okay, so here we will get CuO and here CuO react with HCl will give what? CuCl2 plus H2O. Is it a balanced equation? No. In the right side, you can see there are 2 chlorine atoms and 2 hydrogen atoms. So we will put a 2 this side. So copper oxide plus 2 HCl will give CuCl2 plus H2O. From this reaction, generally we can write it as what? Like this. Okay. Copper oxide means it is what? Metal oxide. Okay. Copper oxide means it is a metal oxide. HCl means it is what? An acid that will give what? CuCl2. What is CuCl2? Yes, it is a salt. Metal oxide plus acid will give salt and water. It will give what? Metal or salt and water. Just now we have seen an equation, right? What was the equation? Acid plus base will give salt and water. And now we have seen metal oxide plus acid will give what? Salt and water. That means both the equation looks somewhat similar. So I'm going to write it again. Here, acid plus base will give salt plus water. Okay. And in the second reaction, we have seen that acid react with metal oxide. Okay, metal oxide will give what? Salt and water. Almost everything are same, right? Both are having acids, both are having salt, and both are having what? Water. Then what is different here? Base and metallic oxide. Okay, metallic oxide. 1 minute, I'll erase that once. Metallic oxide. So here, acid react with the metallic oxide will give salt and water. So we can see that both the sides we have what? Base and metallic oxide. So from here, what we can understand? Yes, you are correct. Metallic oxides are basic in nature. Right? Metallic oxides are what? Basic in nature. While discussing about metals and non-metals, we have already said that base will lose electron. Just like what? Just like a metal. So from here we can understand that base, 1 minute. Once again I'll write it. Acid plus base will give salt and water. Acid plus metallic oxide will give salt plus water. So we can say that metallic oxides are basic in nature. Are what? Basic in nature. It's very important. Okay, so when you consider all the metals are what? Basic in nature. Since it is a very important point, we can put what? Some ticks for all this. So the first one is a neutralization reaction, and second one shows that metallic oxides are what? Basic in nature. And the third one, yes, we have just given the definition, that is metallic oxides are what? Basic in nature. Now we will move on to the third one, that is reaction of non-metallic oxides with bases. Okay, reaction of what? Non-metallic oxides. For non-metallic oxide, I'm going to get an example. Non-metal. Okay, non-metal means where we can find in the periodic table. Mostly will be where? In the right side. So I'm going to get a non-metal, that is carbon. Okay, so I'm going to get what? We will take carbon as the example for non-metallic oxide. Is it an oxide? No, we have here we have only what? The non-metal. So here, if I put a CO2, then it will become what? A non-metallic oxide. This non-metallic oxide will react with the base. Okay, instead of this base, we will take the example as calcium hydroxide, that is lime water. Okay, CaOH twice. Is it enough? Yes. So here non-metallic oxide will be carbon dioxide and the base will be what? CaOH twice. What is CaOH twice? Lime water. This reaction you have already studied. The reaction of acid with metal carbonate. There you have seen that when an acid reacts with a metal carbonate, it gives out salt, carbon dioxide and water. There we will get what? Carbon dioxide. This carbon dioxide we will pass through what? Lime water. When you pass through lime water, you can see that the lime water will turn into what? Milky. What is that product? Yes, you're correct. It is calcium carbonate. What is that? Calcium carbonate. That milky product will be calcium carbonate. Along with that, it will produce what? Water. Along with this calcium carbonate, it produces water. So here you can see non-metallic oxide plus this lime water will give a salt and water. We have already seen an equation like this. I'll just write here, okay? So carbon dioxide means it is what? Non-metallic oxide. Non-metallic oxide plus what? A base. Okay? Plus a base will give what? Calcium carbonate. Calcium carbonate means it is what? A salt, and along with that it produces what? Water. We have studied one more equation just like this, right? What is that? Acid react with what? A base. 1 minute. Okay, so acid react with a base will give what? Salt plus water. That is known as what? Neutralization reaction. So here we have base in common, salt in common, water in common. Just like the last one. Here we have what? Acid in common, salt in common, and water in common. So we said metallic oxides are basic in nature. So from this, what we can understand? Yes, non-metallic oxides are acidic in nature. So what is the final conclusion? Final conclusion is non-metallic oxides. Non-metallic oxides are acidic in nature. Acidic in nature. That's it. Understood? So this is an important equation. So we will put a tick. Okay? So that is what we have studied in the reactions of acids and bases. First we have studied what? The reaction of acid with bases. There we have seen acid plus base will give what? Salt and water. Then we have seen the reaction of metallic oxide with acid. From there we understood that metallic oxides are basic in nature. And next one was reaction of non-metallic oxides with bases. From there we understood non-metallic oxides are acidic in nature. Okay, so these are some examples for the chemical properties of acids and bases. Now we will discuss about what? The electrical conductivity of acids and bases in our next session. Thank you.